All right, so what happens if we have square roots that are not perfect square factors, or they're not perfect squares? So we want to be able to simplify them. A square root is simplified when there are no perfect square factors under the square root. So we want to basically look at something like the square root of 18 and notice that the square root of 18 is not a perfect square, but it does have a perfect square factor. 18 is the same as 9, a factor of 9, times a factor of 2. So what we do is, since it's a square root, we could take the square root of each factor. We're basically splitting it up into two factors. Well, the square root of 9 is 3. That's a perfect square. And then the square root of 2 we need to leave under the radical. So this 3 square root of 2 is a simplified version of the square root of 18. Again, this will help us recognize like radical or like square root terms later on, but to simplify a square root, no perfect square factor. So if we look at the next one, the factors are 50 and x squared. So 50, if we try to recognize, has perfect squares. So it wouldn't help me if I did like the square root of 5 times the square root of 10. Those are factors of 50, but they're not perfect squares. So I only care about perfect square factors. So we could split this up into the square root of 25. That's a perfect square times the square root of 2. And then x squared is a perfect square by itself. So we could split this term up as the square root of 25 times the square root of 2 times the square root of x squared. So the perfect square factors are 25. That's a factor of 5. And then the square root of x squared. So that's a factor of x. And then the square root of 2 we just attach as the last factor. So again, we're taking out perfect square factors. So remember, for number 3, this is the square root of a whole term. So what we're going to do is take the square root of every factor in the term. So the first thing we would do is take the square root of 15 and then over the square root of 49 and then the square root of x squared. So we can simplify the denominator. The square root of 49 is 7, and the square root of x squared is just x. So the denominator turns to 7x. But the square root of 15, the only factors of 15 are 3 and 5, and those are not square roots. So the square root of 15 is actually simplified, and we leave it. All right, so what happens if we have terms that are square roots? What can we do? So to combine like radical terms, well, like radical terms have exactly the same simplified square root factor. So they have to have the exact same radicals, but the idea is that we have to make sure that they're simplified so we can um, compare them. So if we look at this first example, we got 3 terms, right? They look like they're all different. The square root of 20, the square root of 125, and then minus a negative 1 times the square root of 80. So before we can determine if we can combine these, we want to simplify each term. So the square root of 20, we could look at as the square root of 4 times the square root of 5. So 4 is a perfect square. This would be 2 square root of 5. So the term simplifies the 2 square root of 5. The middle term, the square root of 125 is not a perfect square, but we could split that up into the square root of 25 times the square root of 5. 25 times 5 is 125. So this term would simplify to a plus 5, that's the square root of 25, times the square root of 5. And then the last term, first of all, we want to don't forget the factor of -1, but then the square root of 80 is the same as the square root of 16 times the square root of 5. So 16 is a perfect square. So this term would simplify to a negative, square root of 16 is 4, and then square root of 5. So now all of these terms are square roots of 5. We can just combine by combining their coefficients. So the answer would be 2 and 5 is 7, and -4 is 3. So the answer would be 3 square root of 5. All right, so we'll do the same thing for the next problem. Again, we need to separate the terms first. So in this case, there's 4 terms. If you notice, a couple of the terms we don't have to simplify. They're basically already term values. So the first term is an 18 and the last term is a 9. But we do need to simplify 2 square root of 12. Well, this term has a factor of 2. The square root of 12 would be the square root of 4 times the square root of 3. So it does have a perfect square factor. So the 2 square root of 4 is 2, and then the square root of 3. So this term would simplify to 4, 2 times 4, or 2 times 2, square root of 3. So this would be a positive 4 square root of 3. The last, or the second, or the third term, excuse me, we have a -3. And then the square root of 48 is the square root of 16 times the square root of 3. So we would have -3 times square root of 16 is 4 times the square root of 3. So -3 times 4 is -12. So this term would be a -12 square root of 3. So we have all of our term values simplified. 18 and 9, we can combine the 18 and the 9, that's 27. And 4 square root of 3 and -12 square root of 3, we can combine to get -8 square root of 3. Now these terms, because of the square root of 3, are not the same. We can't combine them, so we just leave that. So let's do the last problem then. Again, we're simplifying each term that has square roots first, and then combining. So we'll split the terms. We get a 14 plus 3 square root of 75, and then we got a -2 square root of 12, and then a 2 square root of 48 and -8. So for each of these terms, we want to simplify. So 14, of course, that's already done. So is the -8, that's already done. So can we simplify the factors in the second term? So we have a factor of 3. The square root of 75 is the square root of 25 times the square root of 3. So this would be 3. The square root of 25 is 5 times the square root of 3. So this second term would be a positive 15 square root of 3. The next term, we have a -2 factor. The square root of 12 is the square root of 4 times the square root of 3. So that would be -2 times 2, square root of 4 is 2, times the square root of 3. So the third term would be a -4 square root of 3. And then finally, this other term 2, we have a factor of 2. The square root of 48 is the square root of 16 times the square root of 3. So the perfect square factor of 48 is 16. This would be 2 times 4 times the square root of 3. So this term would be a positive 8 square root of 3. So it gets a little messy, but once you get used to it, working with square roots a lot, you'll start recognizing perfect square factors easier and easier. The terms have to have the exact same square root factor. So all 3 of these terms in the middle are factor or have a perfect square factor of the square root of 3. So we can combine all those terms We have 15 and negative 4 is 11 and 8 is 19. This would be 19 square root of 3. And then, of course, we have 14 and negative 8, which would be 6. So it would be 6 plus 19 square root of 3. So again, the key is to recognize perfect square factors underneath the radical.